Alright, in this video we are going to be finding the maximum angular frequency of a cylindrical cup that can be rotated without causing the fluid to spill over. So we're going to start by drawing some pictures to kind of get an idea for this. So we're going to start with a cup that looks like this. There's a liquid in here at a height of r, and it also has a radius of r. And this whole thing has a height of h. So then what happens is, let's see, okay. What happens is, when we start spinning the cup, the liquid goes up. So we're spinning it at an angular frequency as W. So what we're trying to find in this whole thing is we're trying to solve for this W right here. So we know that this is the center, so this is 0, and this is some point distance away r. So when little r equals big R, we'll be at the edge of the cup, but we are just at some distance in between. We're going to call this level right here the D. And the height from the D to the top, we're going to call HR. So right now, this is what we're working with. In the end, we are trying to solve for W. So the first thing that we're going to do is we are going to use the equation dP over dr equals rho W squared r. So we're just going to do the integral. So we're going to integrate from 0 to p, and we're going to use dummy variables of p, dp prime equals, we're going to pull out the rho W squared, and we're going to do the integral from 0 to r of r prime dr. So from here we're going to have p is equal to rho W squared r squared over 2. But we know that P, the pressure, is also known as rho G H. And once we do this, we can see that the rho and the rho will cancel. So what we're working in is we're trying to find H. So that's why we did that right there. So now this can be rewritten as H equals W squared R squared over 2G. And this little h right here, that is this. So this is equal to W squared R squared over 2G. So now that we found HR, what we need to find is we need to find the height of the dip. So if you think about this, since this is the dip, all the volume that's right here has to equal all the volume that's right here. This is the dip. So we need to find the final height. So to do this, it's going to be R minus the dip plus HR equals H. So basically what that means is we're going to be taking this height, subtracting this height, so that just gives us this little bit, plus HR, which is this little bit, gives us H. So that's just the harder way of saying that this is how we find H, and we need to know all the different parts. So this is where we are in this part. Since we just found HR and we already have R and H, we need to find D. So to find D, we are going to be looking at the volume. So if you look at this a little bit closer, we're going to take little slices of it. And these slices are dr, still with the center equaling 0. And so if you look at it from the top, it's going to look like this, where this little inside part is dr, and this from the center is R. All right, so we're looking at this from the top. Remember, we're trying to find the volume. So to find the volume, we're going to have dV equals h2 pi r dr. So we're going to integrate. The integral of dV equals 2 pi integral from 0 to big R hr dr. Sorry, this is from 0 to... Okay, so lucky for us, we know what hr is. So now we just need to find the integral of hr. So let's go in and replace this. We know that that is just going to be v, so we'll just set that equal to v. So we know hr is equal to w squared r squared over 2g. So we're going to pull out the 2 pi w squared over 2g, and we're going to leave the integral from 0 to r, and this becomes r cubed dr. So let's do this integral. So this is going to be, once we're done, v equals w squared times pi over g times r to the 4th over 4. So once we do the integral, this is what we have. The 2's cancel, and this is what we're left with. So from here, we're going to substitute the volume for pi r squared times d. So v equals pi r squared times d, and that equals w squared pi r to the 4th over oh, this is not over r, this is over 4. That's why I was confused. Over 4, because this is over 4g. Okay, there we go. So now what we're trying to do is we're going to try and solve for just d. So to solve just for d, we're going to get d equals w squared r squared over 4g. Alright, so now that we have our d and our hr, we have all the pieces we need to find w. So what we're going to do here is we're going to rewrite it once I get this revised. Come on. Okay. We're going to write it as r minus this d we just found, which we're going to write as w squared r squared over 4g plus hr, which is w squared r squared over 2g, and this equals h. So now that we're in the end game, we just need to solve for w. So how we're going to do this is this is going to be w squared r squared over 4g is equal to h minus r. So then we're going to have w squared, we're just moving all the stuff over to get w by itself, equals 4g times h minus r over r squared. And then we'll just take the root to get w by itself, so w equals 2 the root of g but this is underneath. This isn't the root. Alright, so this right here, this equation, is the maximum angular frequency that you can spin this cup without spilling any of the liquid out. That is this right here. Alright, thank you.